Hello students. So in this lecture we are going to discuss about redox reactions. Probably you are already aware with this term. We have done this in lower classes. So we are going to revisit and re-understand about this. Now redox reactions are really very important in our everyday lives, and some of the very common reactions like the burning of coal and which gives us energy, photosynthesis, and even the digestion of food which gives us energy, you would be surprised that they are also redox reactions. But to understand those complex redox reactions, it is necessary to first understand the very basic concepts about redox reactions. Now, in this video, I'm going to discuss in depth and in a very simple language the meaning and the explanation of redox reactions. So you may find this video, this lecture to be a little bit more lengthy, but then it touches upon those points which would not be found in other videos which are more straightforward, but rather difficult to understand some finer points. So let's start. So if you go to the traditional concept, then you know that uh, oxidation has been defined as a reaction in which there is an addition of oxygen. So for example, in this reaction, magnesium combines with oxygen and forms magnesium oxide. So here oxygen has been added to magnesium. The addition of oxygen has been defined as oxidation. So for obvious reasons, we will say that magnesium has been oxidized to magnesium oxide. Now let's look at the other example. Look at the second example. So in the second example, this is copper oxide reacting with hydrogen gas, copper oxide solid reacting with hydrogen gas and giving copper solid and water liquid. Now let's observe what is happening in this reaction. So you would observe here that in this reaction, when you consider the change from copper oxide to copper, so in this particular way, you can find that oxygen has been removed. So I'm writing minus oxygen. So oxygen has been removed. And if you consider from hydrogen to water, so in this case, oxygen has been added. So the addition of oxygen is oxidation. So hydrogen has been oxidized to water. But copper oxide has been reduced to copper. So what you find is that oxidation and reduction. So this would be reduction and this would be oxidation. So oxidation and reduction are occurring simultaneously, and such reactions are called redox reactions, right? So you will always find that there is no reaction in which only oxidation takes place or only reduction takes place. Always there will be both oxidation and reduction taking place. So let's go back to this example. I already told you that here magnesium has been oxidized to magnesium oxide because oxygen has been added, but something has to be reduced. So what is reduced here? Now actually the oxygen has been reduced. Oxygen has been reduced. You will find this concept little difficult to understand, but then we will understand it when we go to the further details about this reaction. So now what you actually understood is that we can actually define oxidation and reduction in terms of simple addition of oxygen or removal of hydrogen, right? So now let's go further, and now it has been found that it is much more easier and much more widely applicable and universally applicable when you define oxidation and reduction not in terms of the addition of oxygen or the removal of oxygen, but rather in terms of electron transfer. The reason for that is that actually in all the reactions that take place, it is actually the electrons which are involved. So we should rather define oxidation and reduction with the help of electron transfer. So when we define the oxidation and reduction as electron transfer, this definition that we have used, that oxidation is the addition of oxygen and reduction is removal of oxygen, this definition is still valid, but it is considered from another viewpoint, that is in terms of electron transfer. But this definition does not contradict the previous definition. So let's consider this now. Sometimes it will not be obvious that it is redox, because sometimes you don't even see oxygen. See, for example, here oxygen is not there, so still we can call it as an oxidation reduction reaction, because you have to define in terms of electrons. So let's see this. So one simple shortcut that you can remember is oil rig. Now what is the meaning of oil rig? Oxidation is loss. OIL. Oxidation is loss. Loss of what? Loss of electrons. So oxidation is loss of electrons. Reduction is gain of electrons. So now let us consider this. Sodium reacts with chlorine. Sodium solid reacts with chlorine gas to give you sodium chloride solid. Now here it's a bit difficult, but I will try to explain it to you. Here actually sodium is having a zero charge, because sodium is in the free state, has zero charge. But you know that here sodium is +1 and here chlorine is -1. But here chlorine again, because it is not combined with any other element, so again its charge is 0. So now if you consider this reaction in two parts, then you find that from sodium 0 it's going to Na+1. That means it's happening this way. Sodium is becoming Na+1 here. So this must be due to a loss of electron. Now how to understand this? See, this is 0 charge. So the charge on this side should also be 0. Then only the equation is balanced. And +1 -1 becomes 0. So this is the correct equation. So now because there is a loss of electron, and we define loss of electron as oxidation, so this part is oxidation. Correct? Now look at this part. Here there are two chlorine atoms, and so there are two here balancing. So it forms Cl-. So once again, two chlorine atoms gain 2 electrons and they form 2 chloride ions. So if you want to write for one chlorine, it will be Cl plus 1 electron, right? Gives you a Cl-. So once again, there is a gain of electrons, and therefore the gain of electrons is reduction. So here chlorine has been reduced and sodium has been oxidized. So now you understand that here sodium is oxidized because it involves the loss of electrons. Chlorine is reduced because it involves gain of electrons. So once again, it is a redox reaction. Now, as I was telling you that the previous definition in which we wrote that Mg plus O2, right, gives you 2MgO. So I said that this is oxidation in terms of oxygen because magnesium combines with oxygen, so it's an oxidation. Let us try to apply this electron transfer in this and try to understand whether it is the same. Now see, once again here magnesium has a zero charge because it's free, it's not combined. But here magnesium is combined with oxygen. So here oxygen actually gains 2 electrons and magnesium loses 2 electrons. So it is in this form. So Here again oxygen is 0. So now again, if you consider this in terms of electron transfer, then magnesium has changed into Mg2 plus, so it must be due to the loss of 2 electrons. And I explained to you how to balance this equation. This charge is 0, so this plus 2 and this minus 2, this is also 0, so this is the correct equation. So magnesium loses 2 electrons and it is oxidized. And when we consider in terms of oxygen, then also we can say that it gains oxygen, so it is oxidized. So it gives you the same answer whether you consider in terms of electrons or whether you consider in terms of oxygen. Now I said that oxygen is reduced. Now let us see how oxygen is reduced. Once again, you see this oxygen has 0 charge. Whenever an element is in a free state, it has a 0 charge. So see this oxygen, then it must be gaining 2 electrons. Right? So actually if you consider a single oxygen, then it gains 2 electrons and it becomes an O2 minus. So once again, see, this is 0 and this is minus 2, this is minus 2, so this is balanced. So as I told you previously that magnesium to magnesium oxide is oxidation, but oxygen to magnesium oxide is reduction. So even in this, you find that there is a redox reaction. Now in this, one more point becomes very clear that, see, magnesium is oxidized and therefore we can say that oxygen, we can say that oxygen is obviously an oxidizing agent, right? Because it oxidizes magnesium to magnesium oxide, so it's an oxidizing agent. But oxygen itself is reduced, that you already saw over here. So we reach an important conclusion. And what is that important conclusion? That important conclusion is that an oxidizing agent gets itself reduced. See, the oxidizing agent itself gets reduced because an oxidizing agent actually gains electrons. So if oxygen is an oxidizing agent, then what about magnesium? Then magnesium must be a reducing agent, right? It must be a reducing agent. So because it reduces the oxygen, but magnesium by itself gets oxidized, so we can say that a reducing agent, right, itself gets oxidized. So these are some very basic concepts that you have to understand, that oxidation is the loss of electrons, reduction is the gain of electrons. The oxidizing agent itself gets reduced, the reducing agent itself gets oxidized. So how you apply this in terms of electrons, that also I think you have understood. So this is the very basic idea about oxidation, reduction, the oxidizing agent and the reducing agent, and I think definitely you have understood all this. Okay, so now we will definitely try to understand some of the more important things in the subsequent part of this lecture. Okay, so let's go further. So here also, this, whenever you find this kind of reaction, then this is known as an ionic reaction. So you see, you have been shown only Cu2 plus and the negative ion has not been shown. So when certain ions are not shown, they are known as spectator ions and they have been omitted because they do not undergo any change. So once again, you see here from Fe, it's becoming Fe2 plus, so it must be involving the loss of 2 electrons. So this is oxidation. Cu2 plus is changing to Cu, so it must be involving the gain of two electrons, so it must be reduced. So here Fe is oxidized and Cu2 plus is reduced. So Cu2 plus is an oxidizing agent because it itself gets reduced, and Fe is a reducing agent because it itself gets oxidized. So I think you have understood this. These are some very basic concepts that you have to understand, and hope you have followed, and then we will continue more about this in our next lecture to understand the further concepts. Thank you very much for watching.